Now we'll discuss the question number 52, and it is from EDM. And the question is, a circular hole of 25 mm diameter and depth of this 20 mm is machined by that EDM process. The material removal rate in mm³ per minute is expressed as 4 into 10 to the power 4 into I, which is your current, into that temperature to the power minus 1.23. Now where current is 300 ampere and melting point of that material, which is equal to 1600 degrees centigrade. Now the time in minute for machining this hole is, so we have to find out the machining time, and we are given that this MRR. So the given data is this MRR, this material removal rate in mm³ per minute we have, which is equal to that 4 into 10 to the power 4 into that current into temperature to the power minus 1.23. Now the current given is I equal to 300 ampere and temperature which is equal to that 1600 degrees centigrade. Now we have to drill a circular hole of 25 mm diameter and depth of that 20 mm. So that volume of the the material removal we can find out. So in this case, if you will put this, the value of that current and temperature into this equation, so 4 into 10 to the power 4 into 300 into 1600 to the power minus 1.23, you will get 1374.40 mm³ per minute. This much is the MRR, material removal rate. Now volume which is required, volume required to remove. So in this case we have to drill a circular hole of 25 mm diameter and 20 mm depth. So volume which is required to remove will be equal to pi by 4 into diameter given is 25, so pi by 4 d square into depth is 20 mm. So it will be equal to that 9817.47. This is mm³. Now we have to find out the machining time, right? We have to find out the machining time. So machining time will be equal to that volume which is required to remove, that is volume required to remove upon that MRR. So volume required to remove it is 9817.47 upon the MRR 1374.40. So you will get 7.14 minute. So 7.14 minute. So this much, the time is required to remove this material. So if it is given that MRR is a function of that current and temperature, so the value of the current and temperature is given, so we can find out the MRR. Once we have this MRR, we will find out the volume which is required to remove. Once we know this volume required to remove an MRR, obviously we can find out the machining time by dividing that volume which is required to remove by that MRR.